This one we're just going to do algebraically. I see my circle equation is a little trickier because I have a different center, not just 0, 0. It'll make the process a little trickier, but not too bad. My linear equation is not solved for either variable, so I am first going to solve that for, it looks like x is a little easier because we have a 2y. So I'm going to add 2y to each side. And I'm going to write that over, just leave it right here, and then we'll start the actual process on the other side. So x equals, I'm going to write 2y minus 4. I just think that's a little easier to work with when I plug it in. So I'm going to take that value of x, communicate with my circle equation, and plug that in for x up here. So what that's going to look like is we have our parentheses. Where are the x's? I'm going to plug in 2y minus 4. And then finishing off, we have minus 5 squared plus y plus 3 squared equals 50. Now, I'm going to have a bunch to write, but I'm going to take that one step to simplify what's in parentheses here next. So that's going to simplify to 2y minus 9 squared plus y plus 3 squared equals 50. We'll section this off just so we can see that was our starting value. So we need to write this twice. So I have 2y minus 9 times 2y minus 9 plus y plus 3 times y plus 3, and then equals 50. Here, if I multiply this out, I'm going to use that one-step process. I have 4y squared. My second and third arrow both give me negative 18y, so this is negative 36y. And then plus 81. And in the red section, I have y squared plus 6y plus 9. And then equals 50. So I need to move my 50 over, and I also need to combine like terms. So subtracting 50, I end up with putting a 1 in, 5y squared, and then minus 30y, and plus 40 from my 81, my 9, and my minus 50. I'm going to factor over on the other side, so I'm going to bring that up here. So I have 5 y squared, taken out of GCF, minus 6y plus 8 equals 0. So that gives me 5 times y minus 2, y minus 4 equals 0. 5 equals 0 crosses out, and I get 2 and 4 for my y's. I'm going to split that up and plug it in. I'll use my linear equation. So here, if I plug in a 2, that gives me x minus 2 times 2 equals negative 4. I'm going to add this 4 over because 2 times 2 is 4, and we have negative 4. So that's actually going to give me x equals 0. So at this point, my x is 0, my y is 2. Plugging in the other one, I don't have a ton of room here, so I'm going to try to squeeze it in as best I can. I have x minus 2 times 4 equals negative 4. I'm just going to say this. I'd add 8 to both sides, right? The minus 2 times 4, and I would get that x also equals 4. So this point is 4, 4. So here's my two answers. Kind of tight on room, so I'm just going to leave them not in the set notation. Moving down to the bottom of the page, we have another one that we're going to do algebraically, and then also graphically for this one. So first off, I need to, either variable is easy, so I'm actually going to solve this for y this time just to do something different. So I get 7 minus x. I'm going to take that 7 minus x. I suggest trying this one. I'm going to do this one a little faster, but just try it and see if you can do one on your own. So I'm going to plug it in for y, so pause if you need to. So I have x minus 2 squared plus 7 minus x minus 2 squared, plug this in, equals 9. Writing these out and combining at the same time, 7 minus 2 is 5. So this is 5 minus x times 5 minus x. So we get x squared minus 4x plus 4 plus 25 minus 10x plus x squared equals 9. Combining like terms, 2x squared minus 14x. We're going to also move over that 9. And that's going to give me 20 from 25 minus 9 plus 4. So here's my 3 constants that I'm combining. GCF and factoring. So my 2 answers are x equals positive 5 and x equals positive 2. Plug it in, and we get y plus x, so y plus 5 equals 7, so y equals 2. And then y plus x, so y plus 2 equals 7, so y equals 5. So my 2 points are 5, 2, and 2, 5. So looking at this one graphically, we'll start with a line. I'm just going to rewrite the line down here so we can see it a little better. So I have y plus x equals 7. So if I solve for y, I subtract the x. I'm going to write negative x plus 7. That's just going to make it a little easier to graph. So we'll graph that one first. So y-intercept of 7, and we have down 1 over 1. So there's my line. For my circle, I have a center, I'm just going to look up here, of 2, 2. And a radius is the square root of 9, which is 3. So my center we'll put down at 2, 2. And my radius of 3. So this one is pretty nice and easy to see because I actually, on those like, vertical and horizontal points where I go out, oops, that one's not right, we actually end up. So it's not on the curve of the circle where the answers are. So I have my 2 answers here and here. I'm going to also write my circle equation next. So x minus 2 squared plus y minus 2 squared equals 9. And then somewhere, because I'm solving this graphically, I'm going to write my answers, which are 2, 5 and 5, 2. There's a note, it can be difficult to find the exact point of intersection if the circle is not graphed perfectly. An algebraic method is recommended. So you can see with the uncertainty of graphing a circle, graphing is okay. We show it works. We show it's equivalent to algebraic solutions, but it is kind of easier to do these algebraically.